6A and maybe 6B if we have time. I'm down to about 28 minutes left on this tape, so I want to get this thing done pretty quick. I have a little studio audience. Everybody say something. Hey. Very enthusiastic. They're the ones who didn't go to the musical, so they're stuck with me. And I may be asking them questions as we go. This will be their homework eventually, so at least they're getting that taken care of. The problem, and if you have this, and if you don't have this, you have my website. You can find this Investigation 1 Expansion 6. Crazy Joe Clayton finally gets his souped-up '68 Camaro out of impound. Highway Patrol clocks him at 80 miles per hour. How many seconds will it take Crazy Joe to get to the state border 500 feet away if he maintains a constant acceleration of 8 feet per second? So we're going to follow CL Deepa. I don't have it up here to circle, so I'm just going to go ahead and do the C, the L, the circle, the label, and the drawing on the drawing. So fairly simple drawing again, but I got to get my numbers in there. So he's going at 80 miles per hour. Okay, he's going to accelerate from there. So my V naught is 80 miles per hour. It says it's going to be 500 feet. So there's my delta X. And it's a constant acceleration, so we're not dealing with a quartet situation. So we don't really need the power rule in this case. Don't need to worry about derivatives so much. It's orange equations will solve this one. And we'll see if we run into a snafu though. How many seconds? So we're trying to find t in seconds. So t equals question mark seconds. And one thing I forgot, acceleration is 8 feet per second. So I see I already have an issue there. We have to convert that to feet per second. And you can do that. You can do that within the problem. You can do it before you even get started. I think I'll probably just do it before the problem gets started, so I don't have to worry about that. And so we're supposed to find out how long it takes him to do that. All right. So going at 80, he's going to speed up at that rate, and how far or how long will it take him to get to the border? I guess first thing first, let's go ahead and get this into feet per second. So I got 5,280 feet in a mile, and there's 80 miles per hour. And then I know that's okay to go ahead and do this one. I can combine these 3,600 seconds in an hour, put that on bottom. And so I do my calculating, and I should already have this calculated. Never got that calculated yet. Need a calculator.
It's 117.
117?
Yeah.
You gonna amen on that? Everybody verify that?
Yep.
Sounds right. So 117.
0.3333.
Oh, sorry, 117. And I think.
1/3.
Yeah, and I think that gives me 3 digits, so I'm going to go with that. It's okay to put 0.3, wouldn't matter. Feet per second. So there's my V naught. Okay, so I got my V naught, I got my delta X, I got my A, and so now you look at your 3 orange equations, and you say, which one? I'm trying to find time, so which one do I want? What would you say?
Third.
The third one is great, except it doesn't give time.
Second.
So the second one is the one I want. And so given the information, I want to find time on the second one. So first thing we're going to do, CL Deepa, I'm on the E part, we're going to write the equation down. So I have delta X equals V naught T plus 1/2 A T squared. And now I've got to isolate that. Isolate the variable. Well, there's the problem. I've got to isolate T. Now I did a help video, it's up on the internet, on the orange version of the quadratic formula. But I'll go ahead and run through that real quick. I've got to get this in terms, I got to use the quadratic formula to solve this, and so let me rearrange this, put it in the general form. If I switch this over here and then put the delta X over here, okay, subtract delta X from both sides, then I'm going to switch it so it's equal to 0. So I'm putting it in general form. this is the same thing as saying 1/2 AT squared plus V naught T minus delta X equals 0. Okay, do you see where that's the same?
Yes.
I've just done some rearranging. Now this is in standard form, and so that part is A, I'll make a capital A. That part is B for math. And it's really, the quadratic formula says plus C, right? So it's plus the opposite to put it in those terms. So that negative delta X is my C. Okay, so now I can do quadratic formula because it's the opposite of B plus or minus square root of B squared minus 4AC over 2A. And so I can now put that in that form. Well, for the X then, for the orange, sorry, delta X equals
How
T.
did you know you need quadratic formula? Is it only if you're solving for time?
Yeah, exactly. Only if I'm solving for time. Now, if I was solving for V naught, I wouldn't need it. Or if V naught, thanks for asking the question. If V naught was 0, I wouldn't need it because I wouldn't need to worry about it. But in this case, we have a V naught of 117 feet per second.
Will we need to solve for quadratic formula on any other orange equation?
No, just a second.
Just a second.
Yeah, that's the one you got to worry about. Now there's a long cut, I call it, around this, but then like you can use third and then first. You can use third orange and then come back and do first orange and get it that way. That's a cheap man's way out. And so on the test, I would probably, like on the test come next week or the quiz, I will say you must use quadratic formula to solve. So you're going to have to solve using orange quadratic formula.
So second equation, solving for time, get it into...
You have to do quadratic formula.
You have to get into standard form first.
Yeah, I get into standard form first, but I'll tell you what. Once we get this our orange quadratic formula, then you're not going to have to go through this process every time.
Okay.
Unless I'm asking you to derive it on the test, and I don't know. I'll find that out next week. All right, so the opposite of B, well, that's the opposite of V naught. Plus or minus the square root of B squared minus 4AC, so that's V naught squared, minus 4AC. Well, that's 4 times 1/2 A times negative delta X. So the 4 times a half becomes 2, and the negative makes this a plus. So it's plus 2A, A is in acceleration, delta X, all that's under the radical, and then all over 2A. So the 2A here, 2A, well that's 2 times 1/2 A, that's just A, being my acceleration. That's just an unfortunate coincidence that it happens to be called A. So that right there is the orange version of the quadratic formula. So we call it the orange quadratic. There's a blue quadratic. When we get to blue mirror, you'll see there's another blue quadratic, but this is the orange quadratic. So we can use this now to solve and plug. Basically now it's just to plug numbers into my equation. I can plug my V naught, plug my A, plug my delta X, and I'll get my answer. So I'm going to have to erase some things. So I'll leave that quadratic formula there. Yeah.
Isn't that quadratic formula just the third equation plugged into the first? Because
Well, the thing about the third equation doesn't have anything with time in it.
I know, but the V naught squared.
This looks like, so what you're saying is, this looks like the third, and all you're doing there is solving for time.
Yeah.
So there's your V naught squared, there's your 2, notice remnants from the third orange. There's the V naught squared, there's the 2A delta X, and then you got that's over A and that's over negative V naught over A. You can bring that out. And you could probably then make the case that that's like, by doing a substitution, you're really looking at third. And really, if you remember how we derived these three equations, all three equations came from, I'm talking to the camera now, all three equations came from the three fundamental equations. So they should all be able to transform one into the other. We found out a couple days ago that the first orange is simply the derivative of the second orange. Okay, and now we're seeing there's remnants of the third orange in the quadratic formula for the second orange. Okay, so we're just going to go back in and quickly find time here.
So it would be okay to think of the final. You could think of this in terms of the third equation.
feet?
I don't normally do that, but if you can find a way to make that work, that's cool. Okay, so now I'm just going to plug and chug once I know this. So the opposite of V naught, well, that's the opposite of, 117 feet per second, plus or minus, and we'll talk about that. The square root of V naught squared, so 117 feet per second squared, plus 2a delta x. So 2a is 8, and I have a rule. It gets really tight inside the radical, so inside the radical units are optional, just because we just run out of room. 2a delta x, the delta, and I went in and left them there, but you don't have to always do it, is 500. Okay? And then that's all over just a, 8 feet per second per second. Okay, so I do a quick unit check. I've done my plug, and remember it's really PU because you got to double check units, and yeah, my 8 was okay, my 500's feet, so that's good. So now somebody with a calculator do some punching. Punch, punch, punch. I'm going to cut to the chase here, and apparently if I did my work right, T should be...
Isn't it over 2A?
Yeah, I agree, it's all over 2a, but remember the a for our quadratic formula was 1/2 a, so 2 times a half is 1.
Right.
And unfortunately, I use a capital A for the math A, and then I use a little a for acceleration.
That's confusing.
I know, it's just one of those things that just crops up and it confuses students all year long. 3.8 seconds. When you punch that in, you should get 3.8 seconds. So now the A is to box in and also check for accuracy. So if Joe's moving at 80 miles an hour, he's only 500 feet away. Well, that's a little over, that's less than 2 football fields away. And he's speeding up. He's going at 80 and then speeding up at a pretty good rate. So taking 3.8 seconds is pretty fast, but because he already has it at 80 miles an hour to begin with, it seems like it's possible. Okay, part B says, what would be Joe's speed in miles per hour when he gets to the border? Which equation would you suggest now? What's the fastest, easiest equation to use? We're trying, yeah, first one, right? You could do third. You could do third, that'd be fine, except that, the first one's easier. So, to do part B, I don't have time to do it, but we got a little foosball tournament we're going to play. So V final equals V naught plus AT. All I got to do is plug in 117 right there, plug in 8 there, and plug in now my newly found 3.8 seconds, and I'll get for my answer 100 he's going at 100.5 or 100's fine. Miles, I put it back, I flipped it back to miles per hour. You get it in feet, and then I switched it back. It did say. So you got to do a little conversion. You got to do a little unit analysis, reverse this process to get back to the miles per hour at the end. But that seems to make sense. He went from 80 to 100. Reasonable. Okay. Any last questions before we call this one good? All right. So another help video.